And then what do we do?
Would you like simplify it?
Yeah, so 5 to the power of 1, what's 5 to the power of 1?
5 to the power of 0 is 1.
Yeah, exactly. So, and then you can multiply both sides by x plus 6. Yeah.
Yeah.
So you would get x plus 6 equals x squared minus 3x plus 2. What do you do from here?
You can move everything to one side and like simplify it again.
Yeah, so x squared minus 4x, 2 minus 6 is minus 4 equals 0.
Okay, yeah.
Can we man this? I don't think we can. We're gonna have to use the quadratic formula.
Oh, okay.
I don't think we can fact this. Multiplies to negative 4, adds to negative 4. It's not 2 and 2, so minus 2 and minus 2 doesn't work. 4 and minus 1 doesn't work. Yeah, we have to use the quadratic formula. So A is 1, B is minus 4, C is minus 4 as well.
Okay.
Quadratic formula, x is equals to minus b plus minus b squared minus 4ac all over 2a.
Okay.
Yeah?
Yeah.
And minus b, so just becomes a plus 4 plus minus b squared, negative 4 squared is a 16 minus 4 times 1 times negative 4 all over 2.
Yeah.
So I'm just going to plug that root bit in the calculator. 16 minus, or 16 plus 16 is going to be a root 32. 4 plus minus square root of 32 over 2. Yeah.
Yeah.
So the answer is 4 plus square root of 32 over 2. And one of them could potentially be invalid in the domain of the question. So this one is, you want to leave your answers in exact form, okay?
Okay.
So this is 4.828, just to check if it's in the domain. Yeah, this one is good.
Okay.
I'm going to do the same thing for the minus, and I don't think that's going to be good. So 4 minus square root of 32 divided by 2, that gives me a negative number. Yeah, that one's out.
Yeah.
Yeah, so if I put a negative x in here, I'll get a negative inside. So it doesn't work for both of these. It would work for this one, but
Yeah.
since it doesn't work for both of these, this answer is out. This is the only valid answer.
Can you go over some the exponential equations too?
Sure. Where is that?
It's right in the chapter before it.
These guys?
Yeah.
All right. Any specific questions you had?
There was one with a decimal somewhere. I'm just trying to find it. Oh yeah, can you do 10B?
10b?
10B.
All right, step 1, we're going to turn this into, yeah,
Yeah.
an exponential equation. Yeah, we're going to use b to the power of c is equals to a. So 2 to the power of x is 53.2.
Yeah.
From here, it's easy. Take logs on both sides and drop down the exponent. Right, drop this down.
Okay.
So you get x times log 2 equals log 53.2. So therefore, x is log of 53.2 divided by log of 2.
Okay.
So log of 53.2 divided by log of 2 to 3 decimal places, it's 5.733.
Okay. So like I can. Okay. So I thought it was harder to do.
This one's actually a little bit easier if you use this idea, okay? This is not given in the book, but if you have log base b of a, like in this case, you can rewrite this because most calculators don't have this log base option. You can rewrite this as log of a over log of b.
Oh. Okay.
So this one, we could have written this in one step without having to change this. into this using this rule.
Okay. And that always works?
That always works, yeah. So log base 3 of 2 becomes log 2 divided by log 3. Okay, you don't want to change them into the same base 10s.
Can you do question 8E?
Think so. This one?
Yeah.
Yeah, this one's a little bit annoying. Okay, for this one, we're gonna have to break this apart. You see this?
Mhm.
We want this to be 3x and then something else. Is there any way to simplify that?
Well, you could do like 3x times 3x.
Say that again?
You can do 3x and then times 3 to the power of 2.
Yeah, exactly. That's exactly what you would do. And now you want to factor out 3 to the power of x from the left-hand side of this equation. So you get 3 to the power of x, yeah?
Mhm.
You get 3 squared plus 1 equals 30 with that.
Okay.
From here, it becomes pretty simple because 3 to the power of x times 10 equals 30. Divide both sides by a 10. You get 3 to the power of x equals a 3, yeah?
Mhm.
And you can just put a 1 here. 3 to the power of x is 3 to the power of 1. So the base cancels out. Both the 3's, they cancel out. So x is 1.
So on exponential functions, there's no like restriction.
No, there's no restrictions because the domain for an exponential function is xer.
Okay. Can you go over to like graphing? Um, sorry. Graphing logarithmic functions. I don't think it's in the book, but like, just like in general, how do you like graph a logarithmic function? Because my teacher was saying that you would have to first find the exponential and then do the inverse of it.
Yeah, let me see. There's none in the book.
I don't think so. Like she never gave us homework questions for it, so I don't think it's
I guess I can just make some up. 3 to the power of log 3, yeah?
Oh no, there is. It's like a very short. It's on page 451.
These guys, right? All right.
Not too. They're not like the ones with transformations in them. Oh.
Yeah, there are transformations.
Let me see that. Yeah. Can you do like one of the ones from 4?
Yeah, this one just says say the domain and range, but that's fine. But this one doesn't have all 4. I'm looking for one with all 4 of them. And none of them have all, like, AKDC.
Yeah.
Because we can spice things up a little bit. We can just make up our own, I guess. We're gonna do this one, but with a little twist. I'm gonna put I'm gonna put a -3 here, just so we have all 4 transformations. So we have 1 over 2 log base 10. You don't have to write that. We have -3x minus 6 plus 3. All right, step 1, you want to identify the AKDC values.
Yeah.
Okay, tell me what they are.
A is half.
Mhm.
K is -3. D is 2.
D is -2.
Oh
All
yeah.
right,
Oh yeah. Okay. Let me see.
C is 3, right? So now we're going to use the point mapping rule. Yeah, always use the point mapping rule to turn this into x over k plus d, ay plus c, right?
Yeah.
So this becomes x over -3 minus 2, and then 1 over 2y plus 3. Yeah?
Yeah.
Alrighty, so that's our table for the other one. But for when you're graphing logs, when there's transformations, there's going to be 3 different tables. Now we want to come up with a table for this guy, yeah?
Yeah.
We can make this even more difficult by putting like a 3 here.
Okay.
So log base 3, okay? Now we need to come up with a table for y equals log base 3 of x, okay?
Okay.
So you have x and your y. But this is much more difficult to come up with, yeah, especially if the numbers are weird.
Yeah.
If you have a log of 0.5 or 0.33 or something, it's much more difficult. So what you want to do is to make a table of y equals 3 to the power of x, the inverse of this.
Okay.
Okay, make an x and y table for this one. It's much easier. And then we're going to flip it in this one. Going to flip the x and y because they're inverses of one another.
What if the base was like x minus 2 or something?
No, it won't be. Then you won't be able to graph it.
Okay.
The base will be something you can work with, right? If the base is x minus 1, we don't have a transformation that gives us the base.
Okay.
So you may see that in like a simplifying question, but not a graphing question.
Okay.
So here we're going to come up with a table for this one. So when x is minus 1, y is 1 over 3, yeah?
Yeah.
And you keep going. 0 is 1, 1 is 3, 2 is 9.
Okay.
Now we're going to flip the x and the y. X becomes the y because they are inverses of one another, yeah?
Yeah.
And then the y becomes the x. So that's the main thing about graphing logarithm. You want to flip them.
Okay.
Now from here, it's easy. So 1 over 3 minus, I'm just going to do this part because 0.5 times negative 1 plus 3. So 2.53, 3.54 for these guys. And then for these, you can just plug them in the calculator, yeah?
Okay. Yeah.
Negative 1 minus this becomes this. Negative minus 2.33. 1 over 9 minus 2 minus 2.111. And there we go.
Okay.
And you want to graph this, and this is the final table that you want to sketch.
Okay. Okay. There was one more thing with like simplifying. It was in the section that was called log laws, but like you simplify something and then she gives you values for like the simplified versions and then you plug them in.
Do you know the question?
Oh well, like she gave one for us and it was like square root, like everything is inside the square root of x cubed y squared over w.
X cubed?
Yeah, y squared and it's all over w.
So what are we doing with this?
She says to write it in terms of log ax, log ay, and log aw.
Is there a log on the outside?
No, there isn't.
So how are we supposed to simplify this if there's no logs? There must have been, right? I don't know.
I can send you a picture of it.
Yeah, send me a picture. Let me see what it says.
Okay, I sent it.
Yeah, I think there is a log on the outside. Otherwise, we won't be able to simplify this into logs.
Okay.
So it's like this.
Okay.
Okay. Otherwise, we won't really be able to simplify this because there's nothing here. Step 1, we're gonna get rid of the square root, write it like log of x cubed y squared over w to the 1 over 2. Next step, we're gonna bring the 1 over 2 in the front. 1 over 2 log of x cubed y squared over w, like that. Good?
Yeah.
Now notice here, you have an x cubed plus a y cubed, the logs, yeah?
Yeah.
And then you have a minus w because it's in the denominator.
Yeah.
So there's a plus here and a minus here. So the next step would be 1 over 2 log x cubed
Yeah.
plus 1 over 2 log y cubed
Okay.
minus 1 over 2 log of w.
Okay.
So this becomes 3 over 2 log x plus 3 over 2 log y
Mhm.
minus 1 over 2 log w, and that's it.
Okay. Okay.
Do you have a test on this anytime soon?
Yeah, on Monday.
All right. If you don't
Well,
have a, yeah, if you have any more questions, or we can just try and find a test or something.
yeah, that would be good.
Yeah, let me just look one up. Shouldn't be that bad. Uh, all right, we're gonna work this way, okay?
Okay.
Because we may not have time for everything. So we're gonna do the more difficult ones. I'm sure you're fine with the basic ones.
Yeah.
Now this question, the thing about this question is if you have not seen it before, you won't be able to do it.
Okay.
So yeah, it's an exponential equation. It's asking us to solve for x.
Okay.
How do we proceed?
Well, you could change the 3x squared to 3x like in a bracket and then squared.
So you have seen this one.
Yeah, I have.
All right, there we go.
And then would you like factor out the 3x?
So this one you could, but that won't help you here. You want to turn this. This is actually a quadratic. Okay. This is a
Okay.
quadratic and it's being disguised as an exponential. Okay. This is a quadratic disguised as an exponential. So what you want to do is first step, identify it. Second step, you don't have to do this, but I'll just show you what's going on. You want to do this. You want to make a quick substitution to see exactly what's going on. I'm going to let a equals 3x. So we get a squared minus 7a plus 12 equals 0.
Okay.
And this one's pretty easy to factor, right? That's just a minus 3, a minus 4 equals 0. Yeah.
Mm-hmm.
So that means a is 3 and a is 4. Okay.
Okay.
But we don't want a, we want x. So we're going to replace this. So we are solving for 3 to the power of x equals 3. So
Yeah.
x becomes 1. That's one of our answers.
Okay.
And then we want to do 3 to the power of x equals 4 log on both sides. You get x equals log 4 over log 3. And there you go. Those are the two answers.
And you don't have to check if they would work, right? Like
On this one, yeah, no, it should work because they're both positives. And yeah, the domain here is x is greater than 0.
okay.
In fact, actually, it's an exponential equation, so the domain should work for everything. It's not a log function, so you don't have to check.
Okay.
Let's try doing this one. So it's annoying. This is the applications of log functions, basically the sound, how intensity of a sound.
Um,
This
so
is in the book as well, yeah.
so do you have to do them separately, like one for the person and one for the bird?
Yeah, you'd have to do that separately. So let's first do it for this one.
Okay.
So we have the L singing, whatever, is equals to 10 log, yeah?
Mm-hmm.
where we need to solve for I basically. So we have I over I0.
Yeah.
So we have 90, this is a 90, and then you can divide both sides by a 10 equals log I over I0. Actually, this is going to be IS, the intensity of the singing.
Okay. And the I0 is oh,
I0 is a constant, but the thing about this question is if you do one of them, it's going to cancel out. The I0 from here will cancel out with the I0 of the bird, so you don't have to plug that in. So this becomes a 9, right?
okay. Yeah.
So we have 10 to the power of 9 is equals to IS over I0.
Yeah.
So that means IS is 10 to the power of 9 times I0.
Yeah. Okay.
So that's our first equation. Now we can do the exact same thing for the bird one. 44 over 10 is 4.4. So we're going to get I, the intensity of bird, as 10 to the power of 4.4 I0.
Okay.
Okay, because 44 over 10, yeah, this would be a 44, right? Over 10 is 4.4. And then you want to do 10 to the power of 4.4, that's why.
Okay.
And then they want how much more intense is this compared with this. So it's going to be IS over IB. So 10 to the power of 9 IO over 10 to the power of 4.4 IO, like that.
Yeah.
The IOs cancel out, and then the answer is going to be 9 minus 4.6, whatever that is. Yeah, 4.6, 10 to the power of 4.6. That much more intense, okay? Like 10,000 something. I don't know what that is exactly.
Okay.
Yeah, so this is for the loudness question. Here's a communication problem. Explain why there are no solutions.
Well, the first one you can't have a negative argument,
Hmm.
and the bottom one, I don't know why it wouldn't work. Oh no, actually, because like it would always be 0, right?
Yeah. So here you have 2 to the power of x equals -8 for the first one, right?
Yeah.
So we know the exponential function. This one has an asymptote on the x-axis. So this is y equals 2 to the power of x. It'll never go beyond the x-axis, right?
Yeah.
Because the range is y is greater than 0. So y cannot be -8. That's why for the first one. For the second one, how could we explain this?
Well, it would be like saying 0 to the power of x equals 8.
Yeah, 0 to the power of x equals 8. The
Yeah.
funny thing about 0 to the power of something, 0 to the power of anything is going to be a 0, right? 0
Yeah.
squared is 0. Yeah, exactly. It'll never be an 8.
Yeah.
Or this one.
Okay. Well, this is kind of similar to that other question.
Yeah, I couldn't hear you there for a sec. What'd you say?
So you could do like 5x divided by 5 to the power of 2
Yeah.
equals 4 to the power of 2 plus 4 to, or no, times 4 to the power of x.
Like
Yeah.
this?
Yeah. And then would you do it again, like 4 to the power of 3?
Like that?
Yeah.
Yeah, well, this is right, but this is not wrong. Find your
Oh,
mistake here.
actually, it's 4 to the power of 2, or yeah, 4 to the power of 2, and then x on the outside of the bracket.
Yeah, but you don't have to do that in this case because you do that for the quadratic ones.
Mm-hmm.
You don't have to do that for these normal ones.
Okay.
So this is a 25 here, and this is a 64 here, okay?
Okay.
And now what can we do?
You can multiply 25 on both sides.
25 on both sides, you say?
Yeah.
Okay, let's do that. So 25 times 64. That's 1600 times 4 to the power of 2x, like that.
So you wouldn't multiply the 25 to the 4?
No, you won't. Like if you have something like this, right? You can either do 2 times 3, 6, yeah?
Mm-hmm.
Or you can do 2 times 2, 4. You just multiply them to one of them, but these are not like terms. You can't multiply this with this. This is as far as you can go. That is not 100.
Okay.
They're not like terms. You can't multiply them.
Okay.
So we get that, right? What do we do from here?
Um, can you divide the 4x on both sides? The 4 to the power of 2x?
Let's see if that would that help us? Won't really help us because there's a different base here.
Mm-hmm.
For if this was a 4, yeah, we would do that, but here we have a 5. So we can just take a log on both sides. Okay?
Okay.
So we have a log of 5 to the power of x equals log of 1600 times 4 to the power of 2x. Yeah.
Yeah.
And then what can we do? I guess we can split them up. Log to the power, log of 1600 plus 2x times log of 4.
Uh, how did you know? Oh, okay. Yeah.
Yeah, this becomes a plus log 4 to the
Yeah.
2x, and you can bring that down. Then on the other side, you have x times log of 5.
Okay.
Now you want to bring the logs to the same sides, or the x's to the same sides. I'm going to move this here. So I get x log 5 minus 2x log 4 equals log of 1600.
Wouldn't you move the log 5 also?
This one to this side, you could do that as well. I just moved this to this. It's the same thing. You have to move x's to one side, okay?
Okay.
So I just left this here. I moved this.
Mm-hmm.
So this, and now from here, you factor out an x.
Okay.
So you get x times log 5 minus 2 log 4 equals log of 1600. Therefore, x is going to be log of 1600 divided by log 5 minus 2 log 4.
Okay.
That makes sense?
Yeah.
So this one's a little bit complicated, right?
Yeah.
So yeah, this 4, if we moved it to this side, won't help us that much because they don't have the same base.
Okay.
Yeah, you want to move it if it was like a 2, 8 or something, but with a 5, it doesn't really work. Let's do a quick pH question. You'll be doing this in grade 12 chemistry as well. Did you do grade 12 chemistry?
I'm doing the Excel chemistry right now. So,
Right now?
yeah.
Yeah, so you'll be doing this in one of the
Yeah.
units, yeah, in the acid base unit.
Yeah.
So we have a pH 2.8, and they want us to find the hydronium ion concentration or the hydrogen ion concentration. Any ideas what to do next?
Mm, would you take the 10, like, say
Yeah.
with,
So first you want to multiply both sides by -1, okay? So you get this. And then you want to do 10. Now you do 10 to the power -2.8 equals H plus. And there you go, that's the answer. You can plug that in a calculator, it's gonna be 0.00 something.
okay.
Yeah, log is the pH is very simple, okay?
Yeah.
Here's the population growth. Population growth is the exact same formula as compound interest,
Okay.
where the population after t years is equals to the initial population, 1 plus the growth rate to the power of t.
Okay.
Exact same thing as compound interest. So what's going on here? So P0, the initial population is 76,000.
Yeah.
And then they want to know when the final population will be 100,000. So you have 1.062 to the power of t, because r is 0.062.
Yeah.
From here it's simple. What do?
We divide both sides by 76,000
Yeah,
and then
exactly.
the log of both sides.
And then the t comes in the front, right?
Yeah.
1.062. Did we do logs last year? I don't know if we did logs.
No, we didn't. There was only exponential.
No, I know there was only exponential, but see, this is an exponential question as well. I don't know if I told you this, because you'd have to use guess and check, right? This is a grade 11 question.
Yeah, last year my teacher would make us guess.
Yeah, might have, because the guessing and checking takes forever. It logs is like it gives you the exact answer pretty quickly. Yeah, this one's pretty simple now. You just divide both sides by log of 1.062. And that's the answer on a calculator.
Okay.
Alrighty, what do we do here?
You can take the base 2 of each term and cancel out the log.
You can combine the base two, is that what you said?
No, I said you can take a base 2 like for all of them, and you
Mhm.
can cancel out the logs.
No, you can't. You can only do it if if this didn't exist, you could have.
So I can't. Why couldn't I do it for the last one?
Because there's a plus sign in the middle. So when you're taking base two, right, what you're doing is you're doing the 2 to the power of everything on both sides, okay? That's what you're doing. When there's a plus sign, it doesn't work. Like you can't cancel this out, you see? Plus 3. You can't cancel all the 3's out. X is not going to be 5. You can only do this if there's one base on both sides. So you have to combine this, and only then you can cancel out the base 2's. Right, so that's pretty easy to combine them. You can just do log base 2 of 16, right? Like that. Now you can cancel them out. So 5x plus 1 equals 16. X is going to be 3.
I still don't understand why can't you take the log of all of them?
Why can't you cancel the log of all of them?
Yeah.
Because there's a plus sign here.
Yeah,
You only do that when there's one individual. Like, look at this. How would you do this? Would you cancel out it's the same idea. Would you cancel out all the 3's here?
like if I took a log of everything.
Yeah. No, what would be the next step here? Would you cancel out the 3's? Are you allowed to cancel out the 3's?
No.
No, right? So it's the same idea here. Is that what you meant? I'm not sure if that's exactly what you meant. You want to cancel out all the logs, right?
Yeah, like I was saying, you could like do 2 to the power of everything, and then you could cancel out the logs. Like you would put everything as an exponent of 2.
Yeah, and you can't because there's a plus sign here.
Okay.
If there's only one log base on both sides, you could have same idea here. You can't cancel out the 3's because you're taking log base 3 on all sides, yeah? But they don't cancel out because there's a plus sign in the middle. That changes things. Okay, so you're gonna combine them into one thing before you do that on both sides. Like here, the x is 3, we know that, right? But if you were to cancel out everything, you would get 5x plus 1 equals 8 plus 2, right?
Yeah.
5x equals, what is this, 9? So x would be 9 over 5. If we plug that in the calculator, 5 times 3 plus 1. Yeah, this one is right. This one is not. So you can only do that if they have one item on each side.
Okay.
Like even in this question, you can't just simply cancel out all 3 logs. You need one log on both sides of the equation.
Okay.
So yeah, we can just combine them, right? So this becomes x plus 3 times x minus 2.
Yeah.
And now you can cancel out the log on the outside with this log. Okay? Now you can cancel them out. So this simply becomes equals 3x plus 2, yeah? Now it's just a quadratic and you just have to check it whether it's in the domain of this thingy. So you get x squared minus 2x plus 3x minus 6 minus 3x minus 2 equals 0.
Yeah.
This and this cancels out. So you get x squared minus 2x minus 8 equals 0. So that is x minus 4, x plus 2 equals 0. So x is either 4 or x is minus 2. Yeah.
Okay.
X being minus 2 does not work for this. Because you
Yeah.
would get a log. It also does not work for this. You get a negative logs. So this is not in the domain of the question.
So you can't get a like if it was like x plus 2 and you had negative 2, you can't have a log of 0.
No, you can't. So log of x, it doesn't matter what the base is, x has to be greater than 0.
Okay.
Can't be exactly 0. This one is an exponential decay, okay? Very simple, very similar to the population growth formula, but instead of adding, you just subtract the rate. The depreciation formula. So instead of adding the thingy-majig, yeah, you decrease it. So you can say the intensity of light, again, the notation is whatever. That's equals to the initial intensity, 1 minus r to the power of t.
Okay.
So
How did you know it was
how do I know it was minus? Because reduced.
no, but how did you know to use this formula?
Oh, because they're all the same formula. This is the exact same thing as this, the population growth formula, but a plus.
Okay.
And then the compound interest is the same thing, right? You have something like this.
Okay. So like I would never use like if one of them was like 30% and one was like 15%, so like if you're reducing by like a half or something like that, would I never use like the half-life formula for like
No,
every
half-life formula you'd only use for the half-life questions. This is not a half-life question.
okay. So like it's only for those like questions.
Yeah. So this just becomes I times 1 times 0.85 to the power of t. Okay. And then you can just plug this as 0.4 and then solve for t. It just becomes log of 0.4 over log of 0.85. All right.
Yeah.
So yeah, the main thing here is this equation, which looks very similar. Again, the i's doesn't matter. You can call them z, whatever, doesn't matter. As long as you have a 1 minus r here.
Okay.
And it's very similar to the population growth and the compound interest. This is the depreciation formula as well. The value after t years is equals to the initial value of the car, and then the rate at which it is decaying.
Okay.
Alrighty, this one. How do we start?
You can do 2 to the power of 4. And
Uh, like that.
then,
Yeah, you could, but you don't need to. You could, but that you do this
okay.
for those quadratic type questions, okay? You don't need to do that here.
But like, couldn't you get it as 16 and then do like
No, you couldn't. Don't take it into 16. That's not gonna help you.
okay.
Because you can't write 32 in terms of 16. Because if we're doing exponents, you can't write 32 as a power of 16.
Okay, but could you do like 2 to the power of 4 and then on the oh no, that wouldn't work either.
So you just leave 2 to the power of 4x as 2 to the power of 4x, okay? But the 32, you're gonna rewrite that as 2 to the power of 5.
Okay.
And now you're gonna move this up here. If you move that up there, what do you get?
2 to the power of -5.
Yeah, then there you go. See, now there's only 2 2's on either side, 1 and 2. Now you can cancel them out because there's no plus business going on here.
Okay.
Only in the cases like this, you can cancel them out. So you get 4x equals -5. So x is -5/4.
So when you're canceling them out, are you just taking the log of both
Yeah,
sides?
exactly. You're taking log base 2 on both sides.
Okay.
Here, this one it says write as a single logarithm.
Well, we could do log 6 divided by 3, which is 2.
Yeah, we could do that on that one. What do we do for the first one?
Could you bring the 4 up as an exponent?
Yeah, you could. That's exactly what you would do. So that gives you log of 2 to the power 4 is a 16, right? Yeah. And then you multiply them, right?
Yeah.
And that's the final answer, log 32.
Okay.
Here's a question for you. How would you do this one?
Um, well, maybe you can get it to like the closest number. Like,
So you'd guess and check?
kind of. Like, you
No,
could,
you don't guess and check. You can get the exact answer. Okay, just remember this. You can do this 2 different ways. Either first, you remember this. Log base b of a is log of a over log of b. This one will give you the answer in one step. Alternatively, you can set this equals to a y or an x. So you get 2
oh,
to the power of y equals 91. Y is gonna be take logs on both sides, log 91 over log 3.
okay,
Okay, so it won't be guess and check, it's exact and in 2 steps.
okay.
All right, here. Again, don't cancel those logs.
Okay. Would you do like log 5 to the power of 2 and then log 4 to the power of 3?
Yeah, exactly. So log x equals log of 5 squared plus log of 4 cubed. Yeah. Now you want to combine these two.
Yeah.
So you have log of x equals log of 25 times 64, log of 1600. Only now can you cancel the logs.
Okay.
How are you just canceling them? Because you're raising both of them to 10 to the power of 10 or 10 to the power of log base 10 of 10. That's why they cancel, okay?
Okay.
So x becomes 1600, so D is the right answer here.
Okay.
What's the idea here?
Well, you could do 10 divided by 2 times 8.
Yeah, so you can do log 8 plus log 5, yeah, and then you can just multiply them.
Wait, why did you have it as log 5?
Oh, 10 over 2 is 5.
Oh,
Yeah, 10 over 2, that's what you did first, I think.
yeah.
Yeah, so log 5, and now you multiply them log 40.
Why do you get like different answers if you do them in different orders? Like if you did 8 over 10.
No, why are you doing 8 over 10? 8 times 10, there's a
Oh yeah,
plus.
8 times 10.
No, you won't get a different answer. You'll get the same answer because you do 8 times 10, you have log of 80, yeah?
Mm-hmm.
And then you divide that by 2, you'd get log of 40. So you should be getting the same answer. The order shouldn't matter as long as you do them right. You can even do this with this first if you wanted to. Do 8 over 2 first, 4, and then multiply the 4 with the 10.
Oh, okay.
They should all give you the same answer, okay? The order is not important. I can do one more. Let's try doing this one.
Could you send me the link to that test after?
To this?
Yeah.
Okay. I shall do that. I'll just send you there. Let's quickly do this one.
Okay.
What's the right option?
2n.
Yeah, exactly, because this cancels out, right?
Yeah.
All right, perfect. I'll send you this thing right now, actually. Downloads, boom, boom. All right, I've sent it to you.
Okay, thank you.
And I'll see you next time, okay?
Okay, bye.
Bye-bye.